Alrighty. Hello, everyone. It is Sunday, July 6th, 12:39 p.m. in the afternoon. Yesterday sucked, not gonna lie. Yesterday we spent 2.5 hours doing 3DP problems. I was just not having a good time at all. Today we have one more standard one-dimensional DP, and then I'm moving on to two-dimensional DP, which is just going to be even harder. So I'm gonna probably be having a time. So to cap myself out, make sure I'm having my sanity in check, because the problem is I'm spending too much time on these videos when it hits like 2.5 hours and whatnot, that I'm losing my day to do stuff that I actually kind of enjoy other than interview preparation. So to cap myself out, I will be doing a 40-minute timer, and once that timer's done, I'm just done. Like, either if I'm close to the solution, either I'll maybe give it like an extra 10 to 20 minutes. That way it caps out at an hour. But if it needs more than 20 minutes, then I'm just kind of done. So, yeah, we're gonna let's get that started. Alrighty. So let's move on to the first question of today. A partition equals subset sum. So this is the last question of one-dimensional dynamic programming. I think my issue is, like yesterday, is like I just kind of jumped right into coding. Maybe I need to look more into like actually finding out the recursive relation first. Given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal or false otherwise. Oh, okay. Interesting. Dude, I don't... man. Already, it's just like, I don't know how you would do this recursively. Or not recursively, recursive relation. Yeah. Man, I don't know. Off rip, this confuses me. So you will have like n factorial permutations here, right? So what is this? 4 factorial is 4 times 3 times 2. So this is 24. Nope. It is. Yeah, it is 24. Actually, no. This wouldn't be. It'd be like this. Like 1, 5, 11, 5, 1, 5, 11, 5. One, 5, 11, 5, 1, 5, 5, 11. That's the answer right there. This is brute force right here. There's also another 1, 5, 11, 5. There's 2 of these because of how they wrote it. And then we get to 5. 5, 1, 11, 5. So, as you can see, this blows up like crazy. Okay. I don't know. I'm gonna use a hint. I don't want to waste too much time trying to figure this out. All right. Sorry, I was looking at my phone. So, O of n times t. So dp, the idea is the number of subproblems times take to solve the subproblem. So, and t is half the sum of the array element. What's up, bro? Oh. Oh, wait. I'm curious if the rule is that it has to be like. Oh, it has to be half. Why? Why am I such an idiot? What the hell? No shit. Okay. Well, that kind of. If I think about that I could probably like write a for loop that goes through. It's like I can add, skip, skip or add. Wait, hold on. Let me real quick. Put this in red so that way I know this is a separate section. Okay, so I know that my half equals 11. So what I could do is I can go through, can add 1 plus 5. 11's too big, so I skip it. And then I can add 5. So then I have two operations here. I can add the number. If as long as it's the number is less than like my target minus current, whatever, or less than equal to. Or I can skip, which I can do no matter what. I was thinking like I could do it in a for loop, but honestly it might just be shit, because now this is super specific. It's 2 arrays, 2 things. I mean, I guess the idea is if I reach the end, crap, man, these problems are fucking hard. You gotta wrap your whole brain around a whole different thing just to understand it. Take me back to my easy DPs, bro. Fuck it up. So my decision tree here, I can either take one or I can skip it. So let's say I take it. No, it can't be the end of the array. I could have something like, I was gonna say I could sort it, but that still wouldn't work. I got something like this, like 39, and then like this is just like a bunch of 2's, that up to 40, so 22's, right? And then, you know, this would work. But if I tried saying, oh, we'll do sorted order like a greedy-esque approach, it just that would also not work. Because I was thinking greedy for a second. That wouldn't work either. Dude, god damn, I hate fucking DP, man. Dude, I'm just trying to see if I can come up with like an idea here. I'm like completely stumped. What clock's setting? Damn! 12 minutes already? Alright. So I could go to like a for loop. Take 1. Take 5. Skip 11. And I take 5. That's good. I can also have another for loop where it's like, I take 5. Skip 11. Take 5. That. This creates like an n squared thing, you know? So take 11, skip, good. I don't know. I'm gonna have to use a hint. True. Yeah, that's a good point. No, first of all, let me just, I'll say, sum equals 0. Oh my goodness, don't do this to me. I hate this shit. Okay, and then for element in nums, half sum plus equals element, and then I would say if half sum mod 2 equals or doesn't equal 0, return false, else, otherwise we'll say half sum minus divided by equals 2. And then that's what we'll be running off of. Okay, that's my half sum. Oh. No, I genuinely can't. I guess, by definition, as long as you hit half, you're fine. They're not asking me to return the values. Probably need a cache. It means DP. It's the whole purpose of cache, you know, valuing. Let's see. This is 11. Automatically false. I'm trying to think, man. What do I cache? I don't know. Like, hold on. Again, like, why do you yoink this motherfucker? You're coming over here with me, brother. Oh, crap. Full circle. Alright, we're gonna bring you back down here. Let's try doing forward. So I can include one. Wait, so here's my decision tree. Alright, I can include one, or I could just keep it at 0. And then I get to 5. I can include 5, keep it at 1. Okay. I cannot include 11 here. That does not work. So I can keep this at 6. I cannot include 11 here. So I should keep this at 1. I cannot include 11 here, so I can keep it at 5. I can do 11 here. Or 0. Because of this, I can just immediately return this. But this is BFS. The way I'm probably going to write this is DFS. So you should go one layer deeper. 5. I can include 5 here. Oops. Include 5, which makes it 11. There you go. Where's the cache, though? Like, I see this. I visualize this. I understand this. This makes sense to me. But now I need to understand, how can I cache this? This is where this ends off. This is where this ends off. And this is where this ends off. Okay, so this is at index 0. It's at index 1. It's index 2. It's at index 3. So what is repeating here? Because each of these is different. You feel me? Like, none of these are the same. What exactly is repeating? That's the question. Yeah, no, I agree with you on this, but I don't understand, like, T is half the sum of the array. So this is n equals 4, t equals 11, so 44. A maximum of 44 calls. I mean, sort of, but this one has less than 44 calls. This one's definitely exponential, though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 calls. I'm missing it. I don't see what is repeating. What is repeating, my friend? All right, let's do it with no caching, just for now. We'll set up the cache, but we're not gonna do it with caching. We'll say if sub sum equals half sum, turn true. If index is greater than or equal to length of the nums, then we return false. That means it's out of bounds. Then we'll do solution equals false, and then I'm gonna say include. Okay, there we go. If nums of index is less than or equal to half sum minus sub sum. Right. You can imagine this is like if this is 11 and we had 5 so far, then we would want like something like 6. So 11 minus 5 would be 6. So anything less than or equal to 6 we can use. Then this will be include. So we'll include this and say include equals false. Exclude equals false. I like to just set them up here just because you know, if statements and whatnot. Then include is going to equal the dp of index minus 1. Let's do backwards because I like backwards personally. And sub sum plus nums of index. Alright? Exclude is going to equal dp of index minus 1 and sub sum. We're just gonna add up. And then we're just gonna return include or exclude. And then I'm gonna return dp of length of nums minus 1 0. Okay, let's see what we get from this. List index out of range. Really? Oh, that's why. I said I was gonna climb up, but then I wrote it the other way. Oops. Alright, there you go. So that works, but this has no sort of caching, so if I'm assuming properly, this is going to have a time limit exceeded because it's going to have exponential time instead of the proper caching time. So this will hit probably, I'm guessing, on like question 40 or whatnot. It's usually around that thing. Yep, there you go. Time limit exceeded, it's too much. The question is what is what is the duplicates? Like, he's saying of a 2D array, you know, a 2D array is what he's looking at. Damn, 28 minutes. All right, well, we got like 12 minutes to see if I can solve this problem. I don't know. What's the duplicates, man? What are we duplicating here? Let me look at this again. I don't know. We'll see. Let's do Let's do this. If index not in cache, he does a 2D array. I'm very interested to see what the 2D array actually is, because I'm about to do a 1D, a one-dimensional array here, which is incorrect, or a one-dimensional dictionary, which equates to a 1D array. Is how I'm writing it. Cache of index okay. I don't think that's right though. I think it's only going to solve on these ones because these are like naive. Here you go. Perfect. This is exactly what I thought. So caching on this 1D is not going to work for me. So I need to cache on a 2D. So he says it'll be dimensions of n times t, which is 44 slots. It means we're looking at 44 potential permutations, possibilities. At least for this specific problem. I don't know. Do I do like a index sub sum? I feel like I just don't think this, respectfully, I don't think this would work. I just think this would still have the same speed. I don't think this is actually going to change anything. Memory limit exceeded, right? See, he had a 2D array thing yesterday that he did, but then whenever he actually went to like his like better solution version, he just kind of like completely disregarded all sort of caching. I'm like curious, like, are we going to be doing that right here too? Like, are we going to disregard the caching? Which that confuses me. DP without the caching, like DP with like, I guess the DP without caching is kind of like caching is built into the idea of the problem. That confuses the absolute hell out of me. I mean, like, genuinely. That hurts. Here we go. So these are repeats. Wait, I passed everything. Really? Passed everything, but it exceeds the memory limit. Interesting. Maybe I'll do a 2D array. Okay. Alright, so here's a 2D cache. Let's see. Does this have better memory? Float. What the fuck is going on? What is out of range, my man? God damn it. God damn it. Got 3 minutes left. Like, what the fuck is this? Am I tripping? Like, what fuck are we doing? Okay, here we are. What the hell? Sorry about that. Confused the fuck out of me. Yeah, that'll do. That'll work, I guess. I mean, whatever, man. I guess that'll work. Here we go. Let's try that. Alright, there you go, perfect. I guess the way I wrote it just made no sense. I was trying to do like empty arrays, but here you go, there you go, nice. Fantastic, fantastic. That took 40 minutes to do. I still have some time left in the bank. I'm not gonna have enough time to solve anything. Oh my god. Look at this, look at this. What are you doing here? Oh, edit distance. I remember doing that one. Oh, I remember that one was a motherfucker, too. Look at this. Disgusting. Fucking disgusting. I don't want to do these ones. See how much time do I have? I got about a minute and a half just to read this problem, just to prepare myself for whatever I'm going to work on this tomorrow. There's a robot on an M by N grid. The robot is initially located at the top left corner. Let's reach the bottom right corner. Oh, dude, I remember doing this. Something like this. Dude, I hate DP. I mean, I love it. Like, it's actually kind of a fun concept on the easier problems. But man, when you get to the harder ones, it's just like, fuck. It is a beautiful algorithm, or concept of an algorithm, you know, just because of the idea of, like, you're taking something with exponential time, but because you can see things being reused, you can just kind of like fix that up. The cashier, no matter what's going to be like a 2D kind of situation. So the idea is right here, there is, when you're here, there's one possible solution. Or zero. Well, oh, my timer's done. When you're here, there's like, is it 0 possible solutions? Okay, here you go. Maybe this one might be better. 3 by 2. Let me just draw this out real quick, just so I can see this. 3 is the height, 2 is the length. You like my drawing skills? Alright, my robot is here. My possible solutions, we have 1, 2, there you go, there's 1. Oops. There's 2. There's 3. So the way you triangulate this, we're gonna get green. Let's say this has 0 pathways, so zero solutions. Maybe let's say this is 0 or 1. We'll see. We'll just put 0 for now. This one only has 1 solution. This one only has 1 solution. This one's going to take the number of solutions to the bottom to here. This will be 2 solutions. And it's going to take the solution to the bottom from here. It's going to be solution. It's going to take from these 2, 3 solutions. This is actually, sorry, this is going to be 1 solution here. That's what it's going to be. Yep, so that's how you do this. Ooh, wait. Hold on. I know I said I was only going to do 40 minutes, but this one I actually kind of want to try just for like 10 minutes. Because I think I know how to solve this one. This one kind of excites me. This one makes me geek out a little bit. It's just such a stupid thing to say. Sorry about that. For I in a range of M? No. N. No. M rows. M rows and columns. Apologies about that. Fucking brain. Dot append do of none times n. Okay. Def dp row column. To non-local cache 2D m and n. So I'm gonna say if row is greater than or equal to m, then we're out of bounds, return 0. If column is greater than or equal to n, out of bounds, return 0. Oh, fuck my back. Oh shit. Just trying to pop my neck. Almost fucking squished my spine into 2 little crumbling pieces. God damn, that hurt. Oh god. Alright, cool. Okay. We're gonna go up. If row equals m minus 1 and column equals m minus 1, return 1. There you go. That's the solution. And at the end. Or honestly, the way I could probably write that is a better way of writing that, honestly, my personal opinion actually would be this. Of n minus 1 is equal to 1. So So that way I can just disregard this, because this right here will basically be inside the cache. So now I'll say if cache 2D of row column is not in index. What? Sorry, what am I saying? Equals to none. Then I do this, and then I'll return cache 2D of row column, and I will write here. Crap! I can copy the wrong thing. God damn it. Equals solution salutations, and then I can do right or left. So let's say my right move is going to be dp of row and column +1. Down is going to be dp of row +1 and column. And yeah, my cache is going to be right plus down, and we're going to return that. And so then I'm just going to call I'm just going to return dp of 0, 0, my starting position. That felt slow. Is that slow? And it works. That one's an easy problem. Alright, okay, we're done. Yeah, so we're done. That'll be something we'll look at tomorrow. Alright, well, that video should be quicker than the previous one. I think it was 1:17 when that thing ended, so that was about 50 minutes worth of content. Feel much better today compared to yesterday. I think yesterday I burned myself out a little bit, so today just doing short formed, you know, using the hints when we need them, truly thinking about the problem, not just kind of brute forcing my way until I had to slam my head against the wall. So yeah, that was much better than yesterday. Anyways, thank you for watching, and I will see you tomorrow.